Let's give some definitions related to hyperbolas. And a hyperbola is a set of all points where in a plane the positive difference of which, whose distance from two fixed points called foci, that seems familiar to you, is constant. So the difference between an ellipse and a hyperbola is that in the ellipse we added the distances together, in a hyperbola we subtract them. And this causes our graph to look like this instead. It's like two ellipses turned on their sides, or it could be going up or down. But this keeps going on forever and ever, and this keeps going on forever and ever. So it's like two parabolas, or it's like an ellipse that isn't crossing the right way. They're going away from the center point rather than towards it. Each piece is called a branch. So this is a branch and this is a branch. It's a part of a hyperbola. And every hyperbola has two branches. The standard form is given by x squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. And here we do keep the a squared with the x and the b squared with the y. And so this allows us to talk about our hyperbolas, but the big difference is notice the minus sign between them. One is always positive and one is always negative. The vertices are the points on the axis, so this point right here and this point right here. So there's an axis that goes through the center, and the vertices is where the two branches hit that axis. In fact, that axis between them is the line formed between the vertices is called the transverse axis. And the conjugate axis is found at the midpoint of the transverse, and it's perpendicular. The asymptotes work like most of our other asymptotes, and so this determines the shape of the hyperbola. These are lines that the hyperbola doesn't cross, but it gets close to. And so those are the definitions we need for our hyperbolas.